Hello and welcome everyone. My name is Nur Isanani binti Mazri with the metric number 214458, and today I would like to share with you how to do question 1 using the concept of maxima and minima. So the question asks us to find the closest point on the circle of radius 1 to the black dot as shown below. So what does it mean by the closest point? It means that a point on the circle that has the minimum distance to the black dot, and we can find them using displacement method, or we can do the theorem Pythagoras. So as you guys can see, I already draw the triangle to do the theorem Pythagoras, and so I assume that the point D, which is the closest point to the A, has the coordinate of x and y. So firstly, we have to find the circle equation using the formulas below. X minus h square plus y minus k square equal to r square, where h and k is the center of the point, which is in this case C, which has the coordinate of 0, 0, and r is radius, which is 1. So we just substitute the value, and then we will get x square plus y square equal to 1. After that, we have to find the distance of A and C using the theorem Pythagoras formula, which is AC square equal to x2 minus x1 square plus y2 minus y1 square. And then we just substitute the points, and then we will get AC is equal to 5. And then how do we find the distance of AD? Do you notice that actually the distance of AD is actually AC minus DC? So the distance of AC is 5, and then the distance of DC is the radius, which is 1. So AD we got 5 minus 1. And lastly, we have to use the section formula because we have two sections here, which is D, point D, xy equal to mx2 plus nx1 over m plus n, my2 plus ny1 over m plus 1, where x1, y1 is negative 2, 1, and x2, y2 is 0, 0. And m is AD, n is 1, which is DC. So we just substitute them, and then lastly we get the point D is minus 2 over 5, 1 over 5. So the closest point which has the minimum distance to the black dot is D, which is negative 2 over 5, 1 over 5.
Okay, so hi. Now I will explain the question number 2, which is 16 inches are a combined perimeter of a circle and a square. What are the dimensions of the circle and the square that produce minimum total area? So first thing, I represent the circle and as well as the square. So the side of the square is x, and then the radius of the circle is r. So the perimeter is 16 inches given as in the question. So for the perimeter formula is a 4x because they have 4 sides, and then 2 pi r for the perimeter for the circle equal to 16. And then the total area for the two objects is a equal to x power by 2 and pi r square. X power by 2 for the square and pi r power by 2 is for the circle. Now I'm going to solve the perimeter, which is 4x plus 2 pi r equal to 16, and then 4x we bring to the right, and then 16 minus 2 pi r we bring to the left. So x we get 4 minus 1 over 2 pi per r. Then we substitute the x that we get here into the area formula, which is 4 minus 1 over 2 pi r square plus pi r square. And then we get 16 minus 4 pi r plus 1 over 4 pi 2 r square plus pi r square. And then finally we get 16 minus 4 pi r plus 1 over 4 pi 2 plus pi r square. We factorize the r. And then we differentiate the a, which is minus 4 pi plus 2, 1 over 4 pi 2 plus pi r. We differentiate the a to get the r value, which is a prime equal to 0. And then 6 4 pi plus 1 over 2 pi square plus 2 pi r equal to 0. Okay, so now we're going to solve for the r, which is r equal to 4 pi divided by pi square plus 4 pi divided by 2. And then we get 8 pi divided by pi square plus 4 pi. And we cancel out the pi, we get 8 divided by pi plus 4 equal to 1.1202 inches. And then that r is the radius for the circle. And then we substitute the r value that we get to get the x, which is 4 minus 1 over 2 pi bracket 8 divided by pi plus 4 bracket, and then 4 minus 4 pi divided by pi plus 4 equal to 2.2404 inches. And then we differentiate the a for second time, which is we'll get 2 bracket 1 over 4 pi 2 plus pi close bracket, and we get pi power by 2 divided by 2 plus 2 pi equal to larger than 0. Since a double prime is larger than the 0, the critical point is the local minimum for the area.
So for the question 3, the question asks to show that the area of rectangle is the largest if x equal to 2 set 2 unit and y equal to 2 set 2 unit. So based on the illustration, we can find the radius by using Pythagoras theorem. The formula is r squared equal to x squared plus y squared. And then you solve the equation until you get the y as the subject. So, and then we find the area of rectangle using the formula width times length. So A equal to 2x times 2y. Can get the value from the illustration before given in the question. So A equal to 4xy, and then you insert the value of y from the equation that we get from the Pythagoras theorem. So here it will be 4x square root r squared minus x squared. And then to find the maximum area, we have to differentiate the area, so it will be equal to 0. So first, we must find the derivative of a first. So we solve 1 by 1 for x square root of r squared minus x squared, and then plus 4x square root become 1 over 2, and then you bring in front here, and then 1 over 2 minus 1, and then times the derivative of the value in the bracket. So you will get 0 minus 2x, and then you solve the equation until you get the final and the simplest answer, and then you do what? And then you must equal it with 0, and then you solve the equation until you get the value of x. And then after that, we find the value of y using the Pythagoras theorem equation, and then you will get the value of y, which is the same as the x, that is r sec 2 over 2. And then to prove that the area of rectangle is the largest, if x equal to 2 sec 2 unit and y 2 sec 2 unit, we must find the radius using the value that is given here. So to find the r using Pythagoras theorem again, and then you will get, and then you insert the value of x and y from the question, and then you will get the answer is r equal to 4. So the largest area that you will get by inserting the value from the previous equation, which is 2r sec 2 over 2 times 2r sec 2 over 2, and then you insert the value of r here into here, you will get 32 unit squared, which is equivalent to area without using all the calculation, only using the units in units that is given in the question, we will get 32 unit squared also. So the proof is complete. Hence, the area of rectangle is the largest if x 2 unit and y 2 unit.